So welcome all. Today we'll go for the discussion of the unit complex numbers and quadratic equations under your class 11th CBSE syllabus. Okay. So first we'll start with the discussion of complex numbers. So any number of the form a plus ib where a and b are real numbers is called a complex number. So they're giving a stress on the form a plus ib. So if you look at this form, if I simply write only the number a, it becomes a real number. And why does it become a complex number? When I write the letter I along with it. Therefore I is called a imaginary unit, and the value for I is square root of minus 1, or I square is equal to minus 1, because when I open the square to the other side, square root of minus 1. And also it says I becomes a solution for the equation x square plus 1 is equal to 0, because when you expand this equation to find the factors, you will be expanding it as x square is equal to minus 1. So x is equal to square root of minus 1. And we know under real number system there is no solution for square root of negative numbers. But we can find it under the complex system. So the solution of this equation is I. Okay. So now if I am representing the complex number a plus ib as z, a is called the real part of z and b is called the imaginary part of z. Like for example 2 plus 3i, 2 is called the real part of z and 3 is called the imaginary part of z. So clear with the definition of complex numbers and examples. Yes. Next, when do we say two complex numbers are equal? So if I take two complex numbers in general, a plus ib is equal to c plus id. When do I say both are equal? When a is equal to c and b is equal to d. The real parts and the imaginary parts should be equal to each other. Okay. So next is algebra of complex numbers. So algebra means the four different operations: addition, subtraction, multiplication and division. So here we are going to discuss different properties under these four operations, and I will not be discussing all the four operations. Each property I will discuss, take only one or two operations. Okay. So first we will go for the property, closure property. So what do you mean by closure property and addition? If I take any two complex numbers z1 and z2, the addition of those two complex numbers again is a complex number. This belongs to complex numbers. That's the meaning of closure property. So similarly, if I go for closure property under multiplication, if I take any two complex numbers z1 and z2, again the multiplication of those two complex numbers is a complex number. Here multiplication, I'll be using a dot instead of the symbol into. Okay. Next, commutative property. What do you mean by commutative property? When I add two complex numbers z1 plus z2, that will be equal to z2 plus z1. Okay, z1 plus z2 is equal to z2 plus z1. Associative property. So for associative property, we'll be taking three numbers in general. So let them be z1, z2, z3. So z1 plus z2 plus z3 is equal to z1 plus z2 plus z3. Next, additive identity and multiplicative identity. So what do you mean by additive identity in general? For example, if I take any number, let it be 4. So what's the meaning of additive identity? What number should I add to 4 so that I'll get back 4 again? What is that number? 4 plus 0 is equal to 4. So in general, when we take the case of numbers, 0 is the additive identity for any number. Similarly, when we take the complex number, the additive identity should be in the complex number form. So it is written as 0 plus I 0. Similarly, what is the meaning of multiplicative identity for any numbers? If I take any number, for example 4, 4 into what is equal to 4? 4 into 1 is equal to 4. So 1 is the multiplicative identity for any number in general. Because if I multiply 1 to any number, I'll get back the same number again. Similarly, when I take a complex number a plus ib, the multiplicative identity is 1 plus I0. The imaginary part should be 0. Only the real part will be 1. So a plus ib into 1 plus I0 will be again a plus ib. Next, additive inverse. What do you mean by additive inverse? To the original number, if I add this inverse, I'll be getting back the additive identity 0. So that will be the negative of the number, right? Negative of the original number will be the additive inverse. So the additive inverse of a plus ib will be minus a plus I of minus b. So when you add these both numbers, the answer will be equal to 0 plus I0. So that is your additive identity. Similarly, multiplicative inverse, what's the meaning? When you add the original number with the multiplicative inverse, you will get back the multiplicative identity, that is 1. How will you get it? If the number in general is z, if you multiply it with 1 by z, z cancel, it will be equal to 1. So it will be, multiplicative inverse will be of the form 1 by z. Okay. So now we'll go for the exercise 5.1 under complex numbers. Express each of the complex number in the form a plus ib. So they have given the questions in different form. Finally, I have to write it in the form a plus ib. So the first question is 5i into minus 3 by 5i. So how will I solve it? Multiply 5 into minus 3. So 5 into minus 3 is minus 15. I into I is I square by 5. So when I cancel minus 15 and 5, minus 3 I square. And we know the value of I square is minus 1. So minus into minus plus 3 into 1 is 3. So I am getting the only answer in real part. So it will be written as 3 plus 0i. Understood? Simple solving. But somehow you have to bring it in the form a plus ib. So now we'll come to the question. I power 9 plus I power 19. So if you see I power, we know only the values for I square. So what you have to do whenever you get a question like this, try to write it in I square form. So will I write I power 9 in I square form? First, separate I from this. So this can be written as I power 8 into I. Because when I keep this power as even, it is very easy to write it in the form I square. So always keep the power in even. So I power 8 into I is I power 9. Similarly, I power 18 into I is I power 19. Now, I power 8 can be written as I square whole power 4 into I plus I power 18 can be written as I square whole power 9 into I, because 9 2s are 18. Now, what is I square value? Minus 1. So minus 1 whole power 4 into I plus minus 1 whole power 9 into I. And we know any negative number power even number is positive again. Because if you multiply negative numbers even number of times, I'll get a positive answer. But if I multiply negative numbers odd number of times, I'll get again negative answer. Yes, understanding? Minus 1 per 9 means multiply minus 1 9 times. So I'll be getting minus 1 again into I. So 1 into I is I, plus into minus, minus 1 into I. So I minus I is 0. So which is equal to 0 plus 0 I. Got it? Next, I power minus 39. So this is a different form. So whenever you see a exponent with a negative power, first you will try to make it in the positive power. How will you make it in the positive power? You will take the reciprocal of the number. So I power minus 39 can be written as 1 by I power 39. And again I'm saying you powers, write it in even form. So I power 39 can be written as I power 38 into I. And I power 38 can be written as I square whole power 19, because 19 into 2 is 38 into I, which is equal to 1 by I square is again minus 1 whole power 19 into I, and that is equal to 1 by, what is minus 1 whole power 19? Since the power is odd, again the answer is negative. So minus 1 into I. So by solving that particular step, we got it as 1 by minus I. But I should get it in the form a plus ib, which means I should be in the numerator. So what we are doing is multiply again by minus I by minus I. So what will you get? 1 into minus I is minus I. Minus into minus plus I into I square. Understand? But I square value is minus 1. So minus minus cancel. The answer is equal to I. This is what I written, minus I by minus 1, minus minus cancelled. That's why I've cancelled it. This can be written as 0 plus I because the real part is 0. Understand? Next. 3 into 7 plus I7 plus I into 7 plus I7. So it is just multiplication and adding. 3 7s are 21 plus 3 into I7 is 7 3s are 21 I plus I into 7 7I plus I into I square into 7. Understand? Next. 21 plus I and I can add, no, they are like terms. So 21I plus 7I is 28I minus 7. By minus 7 because I square value is minus 1 into 7 is minus 7. Next. 21 minus 7 is 14 plus 28I. So now it is in the form A plus IB. Okay, simple solving. Again, fifth sum I have not written because it is again similar method. We'll go for the sixth problem. 1 by 5 plus I into 2 by 5 minus of 4 plus I into 5 by 2. What's the meaning of minus bracket? Minus is common to both the numbers inside the bracket. So this is equal to 1 by 5 plus I into 2 by 5 minus 4 minus into plus minus I 5 by 2. That is equal to 1 by 5 minus 4. I have written the like terms together, plus I is common, 2 by 5 minus 5 by 2. So if I take I common, it is easy to take the LCM there. Okay. Now this is equal to 1 minus 5 4s are 20 by 5 plus I into 2 2s are 4 minus 5 5s are 25 by 5 2s are 10. That is equal to 1 minus 20 is minus 19 by 5 minus, why minus again? Because 4 minus 25 is minus 21. So I have taken that minus out, minus 21 by 10 into I. So again in the form A plus IB. Got it? Next question. 1 minus I whole power 4. So we don't know any identity like A minus B whole power 4. So what we are doing is we are reducing it of the form 1 minus I whole square, the whole square, because 2 2s are 4. Expand this using the identity A minus B the whole square. We know it is equal to A square plus B square minus 2AB. So A square is 1 square is 1 plus I square minus 2AB the whole square. And that is equal to 1. I square value is minus 1 minus 2I the whole square. So 1 minus 1 is 0. So remaining is minus 2I the whole square, which is equal to 4I square. Yes, but y square value is minus 1. So 4 into minus 1 is minus 4. Next question. Find the multiplicative inverse of each of the complex numbers. So they are given a complex number. We need to find the multiplicative inverse. What did we learn about multiplicative inverse? When it satisfies z into 1 by z is equal to 1. And the 1 by z is called the multiplicative inverse. So we are going to find 1 by z, that will be a multiplicative inverse. Okay. So first what we are doing is we are taking, let z be equal to 4 minus 3i. Then z inverse denoted as multiplicative inverse is given as 1 by z, which is equal to 1 by 4 minus 3i. But we need to reduce this value. No, so what we are going to do not to reduce it, multiply and divide by the conjugate of the denominator. Understand? So what's the conjugate of 4 minus 3i? 4 plus 3i. So into 4 plus 3i by 4 plus 3i is equal to 1 into 4 plus 3i is 4 plus 3i. This is of the form a minus b into a plus b, which is equal to a square minus b square. And what is this equal to? 4 plus 3i by 4 square is 16. And here I have written it directly. 3 square is nothing but 9. And I square is minus 1. Minus into minus plus. So I have written it plus 9. Okay. And this is equal to 4 plus 3i by 16 plus 9 is 25. So the multiplicative inverse of 4 minus 3i is 4 plus 3i divided by 25. The simple step is just find what is 1 by z, and in order to reduce it, multiply and divide by the conjugate. Now coming to a last question and exercise. First exercise, express the following expression in the form of a plus ib. So they have given the expression. It's very simple, just ordinary multiplication and subtraction. So 3 plus I root 5 into 3 minus I root 5 by root 3 plus root 2i minus of root 3 minus I root 2. So if you see the numerator, it is of the form a plus b into a minus b. So it is written as a square minus b square by root 3 plus root 2i, and minus is common to both the terms inside the bracket. So minus root 3 minus into minus plus I root 2. And this is 9 minus I square, root 5 square is 5 by root 3 minus root 3 cancel. I root 2 plus I root 2 is 2 root 2i. Yes, so that is the answer here. So 9 I square is minus 1, minus into minus plus 5 by 2 root 2i. So 9 plus 5 is 14, 14 by 2 root 2i. Now if I cancel 14 and 2, the remaining is 7. So 7 by root 2i. But I is in the denominator, I need to bring it to the numerator. So what we'll do, multiply and divide by this number in the denominator again. Okay, so root 2i by root 2i. So 7 root 2i by root 2 into root 2 is 2. I into I is I square, which is nothing but minus 1. So minus 2. In the final answer, I have brought that minus to the numerator. So minus 7 root 2i by 2. So this completes your problem. Thank you.